So hi everyone, thanks for coming to the first Stat Club Junior Colloquium. I'm really happy to see a good turnout. My name is Andrew Mullins. I'm Vice President of the Stat Club and I'm a graduate student here in the Master's program specifically. I want to thank the Stat Club for putting this on. If you are not a member yet, you definitely should join because we're trying to do some cool stuff this year. And we'd love to have you be a part of it. That includes maybe having some more of these. So yeah, definitely join Stat Club, and also if you're interested in giving one of these, let someone know. So today I want to talk about RMarkdown, and specifically how it fits into my workflow. So I found RMarkdown to be really helpful for getting documents created quickly and reducing a lot of the redundant work that I have to do. So I guess my basic goal for today is to give you an overview of what I do with the hopes that you can take it and adapt it to your own work. So if you do it, at least for me, it's reduced the amount of tedious work that I do to almost zero. So my brain is freed up to think about the actual analysis or problem I'm trying to solve rather than how to janitor my data around and create my document and all that stuff. So basically the overview of my talk is I'm going to discuss the motivation, why would we want to do this in comparison to how I used to do things. I'm going to talk about how I do things now. I'm going to talk about some of the other tools that have helped me automate the creation of most of my documents, and then I'm going to discuss some resources where you guys can learn more about this. So motivation. What did I used to do? Here's my old workflow. I would do some cool stuff in R. Maybe this isn't that cool, but it fits on the page. I would copy and save the output or the figure or whatever, and then I would paste it into my document, whether that's begin verbatim, put the code or the output of my summary, include the graphics, copy it into my figures folder, whatever you might want to do. And I bet a lot of people do that, and it creates a perfectly serviceable document. But what are the problems with it? Well, the first problem is, what if we need to make a change? What if you made your great document and you realize that, oh, you forgot to delete observation 23 in your data set, you know that it's bad, and that change has to propagate to every single one of your figures. You're going to have a lot of you're going to have to repeat that manual process. That's a waste of your time. Also, LaTeX is hard. It requires a lot of boilerplate code. Like just to write one page that says, hi, my name is Andrew in LaTeX, takes like 30 lines or something insane like that. I don't need those features. It gives a lot of control, but for simple stuff, it's way too time consuming. And finally, thinking about all that crap is distracting. It means that to iterate on my work, to make improvements, I can't just continually be like, oh, what if I made this change? What if I made this change? What does that do to my whole analysis? I have to switch my brain from thinking about my work to thinking about my workflow. Ideally, I never stop thinking about my problem or analysis, and now I don't. I just hit Apple Shift K, and I have my document again, and I can see what happened. So another consideration, if I get hit by a bus, although someone told me not to use that example once, so I changed it to if I win the lottery and have to leave graduate school, is someone else going to be able to pick up where I left off? Or if I'm in a job and I decide to change jobs, will people come after me able to do it? Maybe you don't care about that, but you probably should. In all likelihood, whatever your process is for moving from your analysis, the raw pieces of your data and code and things like that, your figures, to your deliverable is completely undocumented. And whoever comes out, like, how many of you can honestly say that if you were to disappear, I could go onto your computer and figure out how to remake a file you made? No way. Because there's all this shit you're doing where you're like copying output from certain code files and no one knows what's going on. We can do this better in a way that will allow us to see what's going on after the fact. And then I'm not going to talk about this, but it's something to consider, interactivity. We live in the future, why should we be stuck using static documents? And interactive documents are really helpful for demonstrating ideas in your work. And if you use RMarkdown and Shiny, you can make interactive documents to publish to the web. So, what's my new workflow? It's very simple in comparison. I do some cool stuff in RMarkdown. I push button and I get PDF. So more granularly, what does that look like? Can you see this? I don't know if the dark, hopefully it's okay. But basically, this is a very simple RMarkdown document. It's got this stuff, which is a preamble. It's totally optional, but it basically creates your title and tells you how to output it. I write some plain text. Notice there's no like begin document, begin section, whatever. I have an R code block where I do some stuff. Then I have more text and an equation. And then I hit this button, and I get this. I get a really basic file with the preamble information, the text, the code, which is printed here, but there's options to turn that off on a per chunk level. A plot automatically inserted into my document. The R output text, it's split across lines, but again, there's a page, but again, there's stuff we can do to get around that. And these equations don't look very good because I took the screenshot wrong, but they're much more centered on the real thing, which I'll show you later. So now if I make a change, all I have to do is just change it in one place and press the button again, and I have my new output. Which to me is a lot nicer, and like I said, my iteration process becomes very, very rapid. So I'm just basically hitting the same key command again, and I'm getting a new PDF to look at. And I see all my figures, my summary plots, etc. When I'm done, I'm going to show you guys some examples. Okay, so that's one tool, and that's what it's sort of all centered around. In the process of doing this, I've occasionally run into roadblocks that made doing this work kind of annoying, but for almost all of them, I've found ways around it. So I thought that I'd share those with you too, in case you decide to adopt this, you don't have to redo that work. So one problem is, sometimes we do need all that crap that LaTeX gives us, right? You do need like the ability to have the abstract section or the nice packages. Luckily, there's this other really cool thing called Sweave, which is also integrated completely into RStudio that lets us, that's not used, get both the power of LaTeX while still being able to use inline R code. So that, and this is an example that I'll show you more of, but this is from my QEM data thing. So as you can see, I have text and figure information and caption information, and then I have another R code block, and it outputs this, which is really nice. Again, it takes like 1 second to output a new file. So what you're doing when you make a Sweave file is you're literally inlining R code into a LaTeX document. RStudio, you press one button, and RStudio takes it to a text file that contains your figures and your code and your output and whatever you tell it to contain. And then it also makes the PDF for you, which is awesome. Next problem, our output is ugly. Like if we go back here a ways, it's really easy to read and figure out what's going on here, but it doesn't look professional at all. So I found some other packages called Xtable and Stargazer, and what those do is they can output raw markdown, actually HTML, but it doesn't matter, or LaTeX code that gets inserted into your document as is. So as an example, this is also from that QEM. I have my LaTeX code, and then I say some stuff, and then I have my code block, and this echo tells it not to echo the actual code into the file, and results equal as is says, just treat this as raw, whatever this outputs as raw LaTeX code. I have my simple little ANOVA. Then I do print Xtable and the actual summary from that ANOVA, and this creates LaTeX code output from that gets dumped in my document and compiled just like if I were to paste in a LaTeX table, and it looks like this in my file. And it all comes from this code. So if all of a sudden I want to delete one of those factors, or I want to change to like another version of my data set, or I want to remove an interaction term, I just do it. and it changes automatically when I recompile everything. There's another thing called Stargazer, which supports some different R object types and summary data and stuff, and it's very similar. I tell it results equal as is, meaning just don't try and interpret this as past R code, just interpret it as raw LaTeX. Stargazer, infected, keep whatever set of summary statistics. You can read the documentation and figure out what all this means. And it gives me this. Okay. Next problem. Once you start to use R a lot, you begin to notice that some parts of it appear to have been put together by insane people, which is, if you've met many like statisticians, you might understand who those insane people are. Just think of like statisticians in the mid-'80s making the S programming language. As an example, let's take the most common R object we could possibly think of. Just some linear model. This is the output that R gives you, and it's great. You know, like I think by all now we could all say a lot about whatever problem we're looking at just by seeing this. But then I'm like, okay, well I want to extract some of these values and put them into my nice file, you know, so I don't have to copy what the particular intercept is, or the p-value, or this error, or whatever. So, how do I do that? Okay, well, if you start to do enough R, you learn about the str command, which tells you the structure of an R object. If you don't know about that, very awesome. It tells you what's inside something. But if you run it on like a model, this is seriously like the start of like 3 fucking pages of this stuff. And it takes a while to be like, okay, oh, I need to go into here and blah, 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 like extract all this stuff. I hate doing that. There's this really cool package called Broom though, and what Broom does is it gives you this command called tidy, and it creates I had to cut it off, some of the output, because it was too wide for the slide, but it gives you a tidy data set with the output. So this is literally a data frame that's just as easy to work with as data frames are in R. Now, if all this worked for was LM, that would be okay, but maybe not groundbreaking. But here's all the stuff it works for. And I've actually added some new stuff to this package recently, but I don't know what the maintainer is doing. But it seriously works for a lot of stuff, and it'll give you like basically the output you want in a really simple format that's easy to access. Because now, say that I wanted to extract the standard error, what I would do is I would save this tidy output to like some data frame, and I would say data frame $ standard error brackets 1, and I get the standard error on the intercept. And similarly, if I had some crazy lasso thing that I was doing in GLMNet, I could easily extract any sort of information I want from that. Or all this other stuff that I don't know what it is, but probably some of you do. So Broom is awesome. You should check it out. All right, learning more. So I'm gonna go over some examples of some of my files, but I don't really think that it's useful for me to give you a tutorial because you're all intelligent people and you probably know LaTeX, which is really what you need, and you probably know how to write normal text. So the main thing that you need to learn is like the actual RMarkdown. You know R, so all you need to know is how to make RMarkdown or sweep chunks. But basically, to facilitate you learning how to do that, these slides were all created in RMarkdown, so that's something else I didn't mention. You can go straight to Beamer. Also, I put up the sweep file and the PDF for my spring QEM submission, which is like more advanced look at the things that are going on. Sweep and RMarkdown, and contains examples of Xtable, setting different options for Xtable, Stargazer, controlling the size and location of figures, hiding output, reproducing all the code that was hidden, like during your main thing in an appendix. It's lots of cool examples. And that stuff is all up on this GitHub site, which when I send out the slides, this is just a link. There's also built-in documentation in RStudio. So once you've created an RMarkdown file in RStudio, the bar above the code box box kind of changes, and there's one thing that compiles it, and then to the left of it there's like a question mark and a drop down, and if you do that it opens something in the help thing that gives you the syntax. And then if you really want to learn the advanced features, there's this book called Dynamic Documents with RMarkdown by UGA, I don't know, but he works at RStudio and he also wrote Knitter, so I assume that he knows what he's talking about with how to use this application. So that's the end of my slides, but I'm going to show you the GitHub and some examples of some of the things that you can do using this, and then I'll take some questions. Or we can take questions now. Alex?
So I guess my question is, if I'm using Sweep,
Yes.
is there anything that I am not able to do that I would be able to do when using, let's say, a WinEdit editor for LaTeX?
Not that I've found.
Okay.
And in fact, I think that the in RStudio, the text editor is as good or
Okay.
preferable to the.
But so if I've loaded in some packages in WinEdit for my LaTeX code, I can do an equivalent something in Sweep?
Yes, and I think that if I show you
Okay.
this QAM example, it'll be a lot more obvious. So this has like a preamble exactly like you would have in a normal LaTeX file. It has some like other crap that I don't even know if some of this is necessary, but you know, it's like with your LaTeX file, it's like you've been building it up and like who knows. I think the only thing that really matters is this and this error thing. And this is one button too. But notice that it looks exactly like a LaTeX file until you get to these things that start with these carets. And this is what tells Knitter to start an R code block. So it starts with these carets. This first thing is optional, but it gives you a name for it, which you'll see why I do that later. It also helps you navigate because you can navigate faster through the code in RStudio if things are named. Echo equals false tells it, don't spit all the R code that you're about to run into my LaTeX file, which is why I did it for this first thing, because all it is me loading a crap load of packages and writing like my diagnostic plots function that I made. Then it has warn equals false and message equals false because some of these packages give you some warnings and messages for reasons that I don't care about. So then it continues, and if we were in RStudio, which the version of RStudio that's on this computer has given me problems in the past, but let's see what this is. So in RStudio to make new ones, you go into Markdown or Sweep. And in newer versions of RStudio, when you do Markdown, it gives you a pop-up that lets you select different document styles. But this should be, so this will have the syntax highlighting, both in the LaTeX part and in the R code part. Okay, so then this tells it to end. Now if we go into the next code chunk, and see again, this is like using the multi-row package and all that. So I'm pretty sure that what it does on the back end is, first it passes things to Knitter, and what Knitter does is it leaves the LaTeX as is, and it takes those R code chunks and compiles those to LaTeX with particular ways depending on what they are. So if it's a figure, it inserts a figure. If it's code, it inserts it in a way that makes it obvious that it's code, you know, like monotype font and all that stuff. Yes?
So the output or the LaTeX to make that table, did you make that from one of the other X tables at Stargazer, or is that something you put?
This one, well, so what this table actually is sort of like a frequency table, and there is a way to, I think what I did is I made it an X table, and then I was like, I could like, it looks like this, right?
Right.
So I think I made just like a normal table, and then I put it into X table and got the LaTeX code. But then because there was like so much text in here, I was like, I'm not gonna write a script to actually put those counts in. Also, it's a fairly obvious pattern. I just like think that what I did is I used Vim or Sublime Text or some good text editor and entered them all at once. moving on. And then here I'm using, I see you do that normally. Here, see, I even can, I know what's going to come out of this R code because I'm doing it as is going to be a LaTeX figure or something, or a table or something. So I just wrapped it in the normal LaTeX stuff for that to caption it and print it. Using more packages, and it works out like this. So you can really integrate the two things if you want, and save yourself a lot of effort. Also, notice that notice that still echo equals false. So none of the code is coming out, but the results are coming out. Similar. Now I have figures, and there's also figure options in RStudio, so I can control the height of it. So for example, these, in particular, these interaction plots, and by default, they're like half the page, but because I wanted it to look prettier, I made it this size by doing the figure height. But there's other options, and if you're in RStudio, it's got completion, because there's a lot of options that you can read that book to find out about. And again, it's still, none of this is actually echoing out. But here's the cool thing is, since I've named all of these, and you can see the names through here for quick browsing through, then what I do is I have an appended section where it's eval equals false, but echo isn't equals false. So it's not going to run any of this code, it's just going to print it, and then I can back reference to all those chunks up above and easily create my appendix. And it's got nice syntax highlighting when it prints out and everything, so it looks really good. And people are impressed, and it seems like you spent many hours doing it, but it didn't take me any longer than they would have just to write the LaTeX file. It took me less time. Yes?
So from that GitHub thing we're looking at, how much of that was RMarkdown, and how much of that was Sweeve using the packages you were talking about?
All right, so the way this works is kind of confusing. But basically, the difference between RMarkdown and Sweeve is just their syntax. RMarkdown is based on Markdown, which is a really simple text formatting language. So this pen's not going to work because they never work when people are doing these things. But to do bold text in RMarkdown, wow, you do two asterisks and then text, whatever you want to write. And then it knows to make this bold. You don't have to do any. RMarkdown was that first example that I was showing. This is RMarkdown. So it's really simple, just like plain text, and then Sweeve is this R and W file, which is LaTeX with inline R code. If you know how to make the chunks and do the options for the chunks in one of them, you know it for the other. Because what happens is either of those files go into, when you press the button, depending on which of those files type, they both get fed into knitr. And then knitr, based on some options you have somewhere in the file or in RStudio, knows compile this to a PDF or HTML, or what's even crazier is Word. And it can compile things to Word with the equations, equation editable in Word, which is crazy, especially if you work for someone or your professor or something insists on everything being in Word. That could potentially save you a lot of time. Specifically, you see that stuff. This one only has HTML, but there'll be a drop down here that lets you change the output type. Yes?
So, with Markdown, when I've wanted to use a ton of LaTeX, I've had to make header files, load certain packages, and maybe make some custom functions for ones that Markdown doesn't like the function.
If you need to use packages, move to Sweeve.
So Sweeve's
that would be that's basically my quick test for if I need to be doing stuff in Sweeve. Okay. The second that I need something from a package, I'm like, no. Because I think you can technically just surround everything with dollar signs and it sort of works, but it becomes heinous, and like you might as well just do the LaTeX with the inline markdown. Yeah. So that's what I planned to cover. I will take more questions now.
Can
Yes.
you walk through, assuming you get a brand new computer that has absolutely no programs on it, can you walk through the installation process to get to where you are?
Yes. First thing you do you need R installed to install RStudio? It doesn't install it. Well, if you do, install R, but like, I go to RStudio, and then I download RStudio. Now, if I'm in RStudio, and then what I do is I just open RStudio and I do File New, RMarkdown. If you don't have the prerequisites installed, oh wait, you also need a LaTeX installation. So if you're on Mac, whatever, Mac text or whatever that huge thing that takes like hours to download is, I don't know what you would use on Windows. But you need it, and in some cases you might need something called Pandoc, but I've never actually encountered a problem because I have that for other reasons. When you try and make one of these, if you don't have the stuff installed, it pops something up that's like, you need knitr and blah 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 to do this, and then like it's like a dialogue, and then you just hit install, and then it installs all the stuff into R for you. And then you should be able to go.
Okay.
And also that's I think all you need. Yes.
So I have a few questions and comments. So first is, what is exactly knitr? So is it because, is it just compiling different things together, or is there something else there?
The reason it's called knitr is because it knits your combination of Markdown and R, or LaTeX and R, into a LaTeX file.
So what's the difference, let's say, if I'm using Sweeve, what's the difference of using Sweeve by itself versus using it with knitr?
Oh, I see. So, yeah, there did used to be a distinction between those. Sweeve was like the original thing that someone made that would take your...
Yeah, and I mean, I worked with Sweeve like many
Yeah.
years ago, and then
So-
that's, I want to see what's updated now.
In my experience, I tried to get Sweeve working in 2011, and I couldn't get it working, and I just gave up. So I think you can probably, it might be better now, but I don't see any reason not to use knitr because it's the more advanced version that active development is occurring on. That's all supported by RStudio, which is a real company that does have a product for sale, although this is a free one, so they're actually throwing money at it. It also gets you the advantage of being able to do things in Markdown, and I think there's other advantages, like I'm not sure if you can do Beamer presentations using Sweeve, and you definitely can't do any of the interactive document stuff, which I didn't show, but if you've ever heard anyone talk about Shiny,
Yeah.
in RMarkdown you can do interactive documents. There's got to be an example somewhere.
So is this
Like
interactive document, is the syntax the same as in Shiny?
Yes. Well, what you would do to make something like this is you would start an RMarkdown file, and you could type the text just as you normally would, but then in your R code you would include your, you just have the R code chunk like normal, and you start doing the Shiny stuff, and then it knows that you're trying to do this interactive stuff and creates this. Obviously you can't output to PDF, you can only do to HTML, but it creates this for you.
Great. So then there's this server and UI also.
Yeah, but you can also just do it locally, like it'll pop this up in a window, like if you're just experimenting.
Oh, I see, yeah. That's nice. So it sounds like knitr is essentially kind of the updated version of Sweeve, or?
Basically,
So-
and it takes Sweeve input files, which is nice.
But do they support Sweeve now, or they kind of
I think
stopped?
Sweeve is like deprecated, because I don't know why anyone would use it,
Oh, I
you
see.
know, if it's been replaced. I could be wrong, but that's my guess.
So and then another comment is, when I was working on this originally a few years ago, so what I did, RStudio did not exist, I think, at
Yes.
that point. So what I used was Eclipse
Oh.
and actually used R, like, and include all
Yeah.
these plugins, and you can work from there too.
Yeah.
So that's another way to do it.
Yeah.
But another thing is kind of.
Our studio is just so easy.
But yeah,
comparison.
there's so many things that are integrated there. So, and that's what I found is that this type of workflow is great for some documents, like if, especially if some kind of video tutorial where you put R code and have the output. But sometimes if you're working with, at least in my experience, if you want to make some kind of more complicated figure, then it becomes a little bit more tricky. So.
That could be true. For me, you know, it's work to replace everything. I've never just done the like LaTeX. Since I started grad school, I've never really used LaTeX. I just did it all in this. And it's worked pretty well. But I could see there being a point where it wasn't. But I would still encourage you, it's still worth thinking about your workflow, right? Because even if you are doing that, save yourself some time. Have whatever you're writing dump a PDF into your figures folder. Then you don't have to copy and paste any stuff or anything. Make it named the same way every time. Document it.
Right, and that's another thing, documentation, because nowadays there's a lot of emphasis on reproducible research.
Yeah.
So that if you have such a document, you can easily say, okay, this is what I did. You could
Yeah,
report it
exactly. Like if I ever want to look at this like QAM data analysis again, I can see right along with what I wrote the exact things that I did to turn it. I know exactly what I did, which is useful.
So I know like at the start of your presentation you talked about how you get like the weird page breaks in some of the code and some of the output with RMarkdown.
Yeah.
For working around that, would that book that you cite, would that probably be the best way to
It would be, although like I think that the documentation on the RStudio website is pretty good,
Okay.
but
So far I've just like cobbled together a lot of code with like page break commands and things like that that are probably not good practice.
usually I just do that too, but because I don't really care that much. But yeah, if you get this book, or he has a lot of stuff on his webpage that explains the internals of what's going on and the different options you have and stuff. I mean, it's like, ultimately you're still gonna be working, you're not gonna be able to do you're still gonna be going through LaTeX at some point, right? So yeah, it's still gonna be impossible to get the stupid figure to go exactly where you want it to. But on the plus side, that's really the only thing you have to worry about because you don't have to worry about like copying your code and figures and crap over. Okay, well thanks for coming guys. I enjoyed the pizza, sign up for Stat Club, volunteer to do one of these. It's been great talking to you. And I'll send the slides out later along with a link to the GitHub that has all the code on it. Thanks guys.